Good morning. Myself is Belge from Electronic Science Department, Annasaheb Awate College, Manchar. Today I am going to discuss the topic related to T.Y.BSc Electronics semester 4th. Name of the paper is Paper 2nd, Microcontroller and its Applications. The topic that we have selected for discussion is Introduction to Pic Microcontroller. As far as this topic is concerned, previously we have conducted one lecture related with it, and in that lecture I have explained the concept of what do we mean by Pic Microcontroller, history of that Pic Microcontroller families, and architecture related with the Pic Microcontroller. Concerning with the architecture, last time we have studied the simplified view of Pic Microcontrollers with the help of their block diagram, and we have discussed the features related with Pic 1.8 series. Now with reference to that, today we have to continue the same topic again. Further, we have to take into account the details regarding to the architecture of Pic Microcontroller. As far as Pic Microcontrollers are concerned, various subsections are there. Today we have to discuss the register section of Pic Microcontroller, the different types of registers in Pic Microcontroller. As far as registers are concerned, the first question comes in our mind: why there is need of registers inside the Pic Microcontroller? Already we know any CPU of the microprocessor or microcontroller contains various registers inside it. For what purpose? The purpose is that when the internal registers are there, you can able to store the data temporarily inside it, thereby increasing the speed of execution. And therefore, in order to enhance the performance of Pic Microcontrollers, lot of registers are included inside it. Today we have to take into account the various registers located inside the Pic Microcontrollers, especially WREG register, working register. Then we have to take into account Pic file registers, then Pic status register, program counter, etc. one by one. Initially, I will take into account the first type of register inside the Pic Microcontroller known as WREG register. As far as WREG register is concerned, initially you have to remember that it is a 8-bit register located inside the Pic Microcontroller. It is a widely used register during the arithmetic and logical operations. Actually, it is a versatile register, widely used in arithmetic and logical operations. As far as WREG register is concerned, the name is working register, and it is widely used in the arithmetic and logical operations. As far as working register is concerned, similar to accumulator in microprocessors. The microprocessors or microcontrollers are having versatile register inside it. Already you know the name is accumulator. As far as Pic Microcontrollers are concerned, instead of accumulator, WREG register is used. Now in order to explain the theory of WREG register, we have to take into account some operations and instructions related with that. Therefore, by using move and add instructions, we can explain the use of WREG register. Use of WREG register in move and add instructions. As far as WREG register is concerned, we can able to explain their use with the help of simplified diagram. You know, if you call it as a WREG register, this is the ALU related with it, ALU, which is 8-bit. Now this working register is closely associated with the ALU. And the another is here literal, 8-bit literal. ALU generates the result and finally it is deposited in the WREG register. ALU is also associated with the status register. Now with the help of this block diagram, we can able to explain the use of WREG register. If you see this diagram, the arithmetic logic unit ALU is 8-bit and is closely associated with the working register, and it also associated with the 8-bit literal value which is provided by the instruction. In connection with that, there is a status register. Now we can explain their use with the help of two different instructions, that is move and add. From that point of view, here the first instruction we will take into account is move LW with K. Name of the instruction is move WREG with literal value K. Now after execution of this particular instruction, that is move LWK, what happens? The literal value K is directly loaded inside the WREG register, where this K is a literal, takes values from 0 to 255 in decimal or 00 to FFH. That means you can able to place any literal value inside the WREG register by using this particular instruction. Related with that, just I will take into account one example so that you can able to understand the use of WREG register. For example, we will write instruction for write an instruction to load 95H into WREG register. From exam point of view also, examiner can ask a question on that. Write an instruction to load 95H into WREG register. How will you write now? You can able to easily write the instruction move LW. Here we say that 95H. Now after execution of this, here WREG become is equal to 95H. It is similar to the immediate data instructions related with the microcontrollers or microprocessors. I will tell the purpose of this register by using another instruction known as add LW with K. This is the second instruction we are taking into account. The meaning of this instruction is that add WREG register with the literal K. Add WREG register with literal value K. Again, K take the values from 00H to FFH. Concerning with that, I will take into account one example. For example, here we say that MOVL W load WREG register with the value, for example, 34H. And after that we say that add LW with 25H. Now after execution of this particular instruction, after execution of it, WREG is equal to 34H plus 25H. That is equivalent to 959H. As far as these two examples are concerned, by using these two instructions we can able to explain the use of WREG register. Shortly we have to remember that WREG register is widely used in arithmetic and logical instructions. One of the literal value is placed in WREG directly, another is provided directly by the instruction. Arithmetic logic operations are carried out. The status register is also affected by it. And finally, you have to remember that the result is placed again inside the WREG register. In this way, this is a versatile register, anyhow we have to keep in mind for programming of Pic microcontrollers either in SMD or C language. Now we will proceed towards the another type of register known as Pic file register. The another important register for discussion is nothing but the Pic file register. As far as Pic file register is concerned, in Pic microcontroller family, the data memory is known as file register. Therefore, shortly I will write here data memory of Pic microcontroller is known as file register. File register. As far as Pic 18 family is concerned, the maximum data memory available is 4096 bytes. It is also known as static RAM. Actually, it is a SRAM, static RAM for read-write operations. Therefore, as far as Pic file registers are concerned, you can write the information inside them at any time, or you can able to read the data from it. From that point of view, we say that it is a static RAM. And this data memory is in Pic language, it is known as file register. For what purpose this file register is used? It is used as a scratch pad RAM for data storage or for address storage, etc. It is also used for specific functions, for internal operations, As far as Pic microcontrollers are concerned, this file register is divided into two parts. The file register is divided into two parts. Number one is known as special function registers, shortly abbreviated as SFRs. Special function registers, shortly abbreviated as SFRs. Where these special function registers are used, they are related with I/O ports, timers, ADC, serial communication port, etc. Now, in order to carry out these variety of operations related with the ports, timers, analog to digital converters, or serial communication ports, the special function registers are always required. Meaning is that they are only having only one function. From that point of view, we are calling them as special function registers. The another part of this file register is known as GPRAM, general purpose registers, shortly abbreviated as GPRAM, and this is used as a scratch pad memory area. This is used as a scratch pad, means you can able to write any information inside it, or you can take the information from it. From that point of view, at least we have to remember that the file registers of PIC1 family are divided into two parts, special function registers and general purpose registers, shortly abbreviated as GPRAM. Now, as far as PIC18 family is concerned, PIC18 family is concerned, with reference to that, we have to discuss the PIC file register. As far as this family is concerned, in the previous lecture I have told you the features, and PIC18 family is having a maximum data memory of 4096 bytes. In short, we say that 4K bytes. 4096 bytes data RAM memory is maximally available in case of PIC18 family. Now, if you calculate the address range for that, the addresses related with that, addresses related to it ranges from 000H to FFFFH. Now, by using this address space, you can able to study the PIC file register associated with it. With the help of diagram, we can write this particular data memory as like this. Here the starting address is 00H and the maximum address is FFFFH. Now, this total memory area is divided into sub-parts known as banks. Here I say that this is bank number 0, which is related with this bank number 1 is related with GPRAM, half part of that. Then here we say that bank 1. In this way, there are totally 16 banks are there. Bank number 15, 0 to 15. Now, with reference to this particular diagram, here you can clearly understand that the total data memory 4096 bytes is divided into 15, total 0 to 15 banks. Each bank is having a 256 bytes. Each bank has 256 bytes. Now, 256 multiplied by 16, you are getting the figure that is 4096. I think you have understood clearly the PIC file register data memory space associated with the PIC18 family. Each bank is 256 bytes. Now depending upon the Pic family member, the number of banks go on increasing. They may be smaller or maximally they may be 16. The last bank, in the last bank, the half part is related with SFRs. Half part is related with SFRs. This is very important for understanding, because with the help of that, we have to explain the concept of what do you mean by access bank. What do you mean by access bank? Access bank in Pic Microcontroller. Remember that any Pic Microcontroller is having at least one bank, minimum one bank inside it. That particular bank is known as access bank. Each Pic Microcontroller has at least one bank known as access bank. Remember that all these particular banks, they are related with the segments, segment 0, segment 1, like that. Come back again. Each Pic microcontroller has at least one bank inside it known as access bank, and is a default bank. Default bank. What is the meaning of that? Whenever the Pic microcontroller is powered on, automatically the access bank will be selected. Automatically the access bank will be selected. Now each access bank contain GP RAM and SFR. GP RAM and SFR. Here I will draw the simplified view related with the access bank in brief. The memory area, data memory area ranging from 00H to 07FH, means 120 bytes, is related with GPRs, GP RAM. While the last memory area 0F8, 0H to FFH, FFFH, is related with SFR. From that point of view, these are 128 bytes. These are also 128 bytes. First one is related with GP RAM and this is related with SFR. This is the access bank in Pic microcontroller, and whenever the Pic microcontroller is wake up or it starts, at that time automatically the first bank will be selected, that is known as access bank. Whenever the Pic microcontroller contain many general purpose RAMs, at that time the switching mechanism is used, switching of banks. Therefore, you should have some knowledge regarding to the switching of banks. Automatically there is a mechanism related with the switching of banks. How this is done, there is no need to go into the details of that. In this way, as far as Pic file register is concerned, shortly you have to remember that what do you mean by Pic file register? Divided into two parts, special function registers, general purpose RAM. Related with Pic 18 family, the block diagram I have explained to you, showing the details regarding to the file register. And in connection to that, you have to remember the meaning of what do you mean by access bank. Any Pic microcontroller at least have one bank inside it. We are calling it as a access bank. In this way, I think this is the brief discussion regarding to the second type of register associated with Pic microcontroller family, known as file register. And now I will proceed towards the next important register inside the Pic family, known as the Pic status register. Pic status register. This is the third type of register we will take into account. As far as Pic status register is concerned, again you remember that it is a 8-bit register. 8-bit register, also known as flag register, Many times previously in microcontroller literature, for example related with 8051, we have studied the theory of flag register. Any CPU, any microcontroller chip has at least one register inside it known as status register or flag register, and it is used to indicate the conditions related with the arithmetic and logical operations. The flags are used to indicate the conditions after arithmetic and logical operations. That means after execution of arithmetic and logical instructions, what will be the status of CPU, that will be indicated with the help of a register known as status register, or some people may call it as a flag register. As far as Pic status register is concerned, there are different types of flags in Pic register. The different types of flags, they are carry flag, then we say that digital carry flag, then 0 flag. Next one is here we say that overflow flag, and last one is nothing but a negative flag. Totally in Pic microcontroller family, these 5 flags are used. Totally there are 5 flags. Now these flag conditions, they are reflected inside the register. We are calling it as a Pic register. And in the same lecture we have studied that this status register is associated with the arithmetic logic in it. It is closely associated with the ALU. As far as Pic status register format is concerned, it is important to understand the corresponding format from exam point of view also. This is a 8-bit register. I say that D0, D1, D2, D1, D2, D3, D4, D5, D6 and D7. These are the 8 bits. These 3 bits are not used. The first D0 bit is associated with the carry flag. Just here itself I will write this as a carry flag. Next one is related with DC, meaning is that this is a digital carry, shortly abbreviated as DC. Then next flag is known as 0 flag. Next one is known as OV flag, overflow. And last one is known as negative flag. These 3, they are don't care, not used. These bits are not used, kept for future use. These 3 bits are not used, remaining 5 bits are used. Totally remember that this is the status register of Pic, status register. After execution of arithmetic and logical operations, what will be the status of ALU? that will be reflected inside the register. We are calling it as a status register. Lastly, I will explain the purpose of each and every flag in brief. Purpose of each and every flag in brief. Purpose of each flag. First one, we are calling it as C, carry flag. When there is carry generated from D7 bit during add or subtract operations, the carry flag sets to 1. When carry is generated from D7 bit during add or subtract operations, CY flag sets. CY flag sets. Therefore, whenever there is generation of carry from the MSB bit position, the carry flag sets to 1. Second flag related with it is known as DC, means digital carry. I will write here in brief only. The digital carry is generated flag sets when there is carry from D3 to D4. Whenever there is carry from D3 to D4, at that time the digital carry will be generated. It is similar to AC flag. And this flag is generally used in BCD arithmetic. This is used in binary coded decimal arithmetic. The third type of flag we will take into account is known as zero flag. Whenever the result generated by the ALU is 0, the Z flag sets. When ALU result is 0, Z equal to 1. Otherwise, the corresponding flag is in reset condition. Whatever may be the result generated by ALU, whether it is 0 or not, this condition will be verified with the help of a flag. We are calling it as Z flag. Similarly, I will take into account the remaining two flags in brief. OV, overflow flag. Whenever there is carry from D6 to D7 in signed arithmetic, when a carry is generated from D6 to D7, the flag sets. It is used in signed binary arithmetic. Remember that the C flag is used in unsigned binary arithmetic, while the OV flag is used in signed binary arithmetic. And the last flag I will take into account, known as negative flag. You know, the D7 bit always indicates whether the corresponding data is positive or negative. When D7 bit is 0 in signed arithmetic, it indicates that the result is positive. And whenever it is 1, it indicates that the result is negative. Whether the result generated by the ALU is positive or negative, that will be internally reflected inside the flag. We are calling it as a negative flag. In this way, shortly you remember that as per as our Pic microcontrollers are concerned, 5 different flags are there, namely carry flag, digital carry flag, zero flag, overflow flag, and negative flag. I think this information is sufficient regarding to it. Just I will tell one example corresponding to it, which may be asked in the examination also. Now, in order to explain that particular things, I will take into account one example in brief. What is the status of, or we say that determine the status of C, DC and Z flags after execution of instructions. Here we say that move LW with 9CH and add LW with 34H. The example that we have taken into account, we have to discuss the effect of these instructions on the status flag. After addition of these two numbers 9C and 34H, what will be the status of carry flag, digital carry and Z flag? Just we have to decide the corresponding values. As far as solution is concerned, if you do the job of addition of 9CH with 34H in hexadecimal, C is equivalent to 12 plus 4, 16, means here there is a 0, 1 0. Then here we say that 9 plus 4, 9 plus, here we say that 312 and 1 equivalent to D, equivalent to D, D0H. Now if you do the same things in binary, because this is simple to understand, 9 is equivalent to 1001, C is equivalent to 1100, plus 3 is equivalent to 0011 and 4 is equivalent to 0100. Now if you do this addition, 0 added with 0, 0, here again 0, 1 added with 1, here you are getting 0, there is a carry from here, 1 added with this, again you are getting 0, here there is a generation of carry 1, here 1 plus 1, 1 0 plus 1, 1 1, here there is a carry 1 plus 1, 0, there is a carry 1 and here 1. That means this is the result which is generated in the WREG register. Now if you look towards this particular result, as far as carry flag contents are concerned, here there is no generation of carry from the D7 bit, therefore the carry flag contents, they are 0, CY is equal to 0. If you go towards the content of digital carry, you know whenever there is generation of carry from D3 to D4, here there is generation of carry, therefore the DC flag sets to 1. And finally, what about 0 flag? Is nothing but the result of operation is not 0, therefore Z is equal to 0. In this way, by taking into account different values of the operands, you can justify the status of the register known as file register, also known as status register. I think you have understood the concept of status or file register in brief that I have described here. And lastly, in 2 minutes I will take into account the concept of versatile register inside the microcontroller known as program counter. Program counter, shortly abbreviated as PC. Shortly abbreviated as PC. What is the purpose of program counter? You know, it keeps the sequential track of execution of program. Before execution of next instruction, the address will be generated by the PC. Shortly, here we say that PC point out the address of Next instruction. To be executed. To be executed automatically. From that point of view, I have told you, program counter always keeps the sequential track of execution of main program. For that purpose, internally there is one register inside the CPU known as program counter. PC is not a meaning like personal computer, it is the register located inside the CPU of the microcontroller. As far as Pic 18 family is concerned, related to that, you know, the program code memory size, maximum program code memory size is 2 megabyte. 2 megabyte. What it indicate? Mega means 2 raised to, here we say that 20, 2 raised to 20. Therefore, this is equivalent to 2 raised to 1. Mega means 2 raised to 20. This much amount of bytes. You are getting 2 raised to 21 bytes. This directly indicates that, therefore, we require program counter. Program counter is 21 bit wide. Program counter is 21 bit wide, so that our controller can able to access the maximum memory capacity of 2 megabytes. I think you have understood this logic. Many times we have done these particular calculations. In order to access the maximum memory of 2 megabytes program code memory, our program counter must be 21 bit wide. And how it is represented, just I will tell in brief only. Here we say that the lower 8 bits are known as PCL 8 bits wide. Remaining 8 bits, they are represented by the letter that is PCH. This is known as high order byte of the program counter. This is known as low order byte of the program counter. Here remaining 3 bits are not used. They are kept at 00, and this particular is known as upper part of PCU. Again they are 8 bit. But from that 3 bits are completely kept at logic 0. In this way, by using 24 bit wide program counter, you can able to access the memory having a capacity of 2 megabytes. 2 megabytes. And lastly, you remember that in case of Pic microcontrollers, whenever the Pic microcontroller power is made on, the content of program counter starts from 000H, and therefore you have to keep the programs inside the memory starting the address from 0. Starting the address from 0. I think today this is sufficient one. I have explained different types of registers associated with the Pic microcontrollers. Shortly, or namely, we say that WREG register. Secondly, we have taken into account Pic file register. Thirdly, I have explained the concept of access bank related with the Pic microcontroller. And lastly, I have told you the Pic status register, and last one is nothing but a program counter. All these are the versatile registers associated with the Pic microcontrollers. During programming, many times we have to take the help of them. Okay. The remaining part of this particular topic is related with the special type of Pic microcontroller known as Pic 18F4580 Pic microcontroller. Their features already I have told you, and for programming of such type of microcontrollers, the software used is nothing but a MP lab. MP lab. Their I/O port structures, memory organization, all they are included, but they are not included as far as our syllabus is concerned. Therefore, today we will stop here only. Thank you very much.